Hi guys, welcome back to my channel. For today's video, we're going to talk about the probability of compound events, or the first part is the union of two events. For the reference of my students, you can read from 315 to 321 of your books. So before we start with our discussion, please don't forget to hit the subscribe button and the notification bell for more videos. Right? So these are the learning competencies that we need to achieve in this discussion. So first, we have to illustrate events and union and intersection of events. Illustrates probability of union of two events. Finds the probability of A union B. Illustrates mutually exclusive events and solves problems involving probability. Now, what do we mean by compound events? So in the previous discussion, we have talked about probability of an event. Okay, so in this case, compound events means these are events that happen more than once. Okay, so compound events that happen more than once. Just like for example, if you're going to pick a card from a deck of cards, so what's the chance of getting king of ace or ace? Okay, so there are two events there. So this is just the chance of getting a king or ace. Okay, so let's talk about union. So when we say union, combining of two sets. So we are talking about the whole elements in the set. Okay, so when we say intersection, common elements of sets. So if there are common elements between the two sets, okay, so we call them as the intersection of the two sets. Okay, so what do we mean by mutually exclusive events? So when we say mutually exclusive events, there is no intersection or there are no common elements between the two sets. So that's the difference between intersection and the mutually exclusive events. So intersection is not applicable for mutually exclusive events. Events that do have intersection, we call them non-mutually exclusive events. So if there is something common between the two sets, okay, non-mutually exclusive events. But if there are no common things or elements between the two sets, we call these events are mutually exclusive events. So let's talk about probability of union of two events. So this probability, if A and B are in the same sample space, then the probability of A or B occurring is probability of A or B or A union B. So in this specific topic, union of two events, you can say that the two events talks about union, okay, if we have the word or. And then, how can we solve for the probability of union of two events? So probability of event A plus the probability of event B minus the intersection. So if there is intersection, we call this as non-mutually exclusive events. Okay? So this is the formula if there is an intersection or if there are elements that are common between the two sets A and B, or probability of A and probability of B. What if there is no intersection? Okay? So if there's no intersection, so if A intersection B, this symbol means intersection. If A intersection B is an empty set, then A and B are mutually exclusive events. So therefore, what's the formula? All you need to do is to add the probability of the first event A plus the probability of event B. You're not going to subtract the probability of the intersection because it's an empty set. Okay? There is no common between the two sets. Okay, so in this case, the events are mutually exclusive events. So in the first formula, we are only using this if there are common between the two sets. So if we're going to draw the universal set, okay, so let's say this is the universal set. So if there is an intersection between sets A and B, we can say that these events are non-mutually exclusive events. But if the sets goes like this, and this is the universal set, A and B, there is no intersection between the two sets, so therefore we call this as mutually exclusive events. So I do hope that you can actually follow the discussion. So the first formula, you're going to subtract the intersection, while in the second formula, we cannot subtract anything because there's no intersection. Let's proceed. Example number 1. So let's have the first example here. Okay. 15 balls in a jar are numbered from 1 to 15. A ball is drawn at random. Find the probability that the number on the ball is A less than 6, B greater than 9, C even, D less than 6 or greater than 9, and E less than 6 or even. So let's talk about this one. So as you can see, the first three questions are probability of an event or simple events. So all we need to do here is to divide the number of favorable outcome over the total number of possible outcomes. So that is the probability formula for the probability of an event. And then for letter D and E, these are compound events. And then how are we going to know that this talks about union of two events because of the word or? Remember, if this word is and is different. So we are going to use different formula because this falls under probability of compound events and not union of two events. So let's proceed. For letter A less than 6. So how are we going to compute? 15 balls in a jar. Jar is our universal set, numbered from 1 to 15. So for the universal set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have 15 balls numbered from 1 to 15. So that's our universal set. Now, let's rename less than 6. Okay, the numbers that are less, the probability of getting less than 6. So let's rename this as probability of event A. For greater than 9, let's rename this as probability of event B. And for even, let's rename this as probability of event C. So let's talk about first probability of event A, less than 6. So what are the numbers in the universal set that are, or voles that are less than 6? We have 1, 2, 3, 4, 5. Okay, so therefore the elements of A are 1, 2, 3, 4, and 5. Then how about probability of event B or greater than 9? So for greater than 9, okay, so let's have the numbers that are greater than 9, 10, 11, 12, 13, 14, 15. So let's write them. Greater than 9, we have 10, 11, 12, 13, 14, 15. And then probability of event C, okay, even, getting an even. So we have 2, 4, 6, 8, 10. So let's talk about the even numbers. 2, 4, 6, 8, 10 until the 14th. Okay, so 2, 4, 6, 8, 10, 12, 14. How many are the elements in probability of event A? We have 5. Here, probability of event B, we have 6. And then probability of event C, we have 2, 4, 6, 7. Okay, so we can now solve for each. Okay, so let's have first less than 6. So for less than 6, remember that we have 15 balls in the jar numbered from 1 to 15. So probability of event A or getting a less than 6 is favorable outcome, we have 5 over total number of outcomes, 15. Okay, so if we're going to simplify, the lowest term of 5 over 15 is 1/3. Okay, so let's not have the percent yet because we're going to use the answers in A, B, and C to D and E. So the probability of getting less than 6 is 1/3. Now let's have letter B, greater than 9. So this probability of event B, the favorable outcomes, we have 6. 6 over 15. So if we're going to simplify this in lowest term, this is 2 over 5. So that's 2 over 5. Okay, let's proceed to letter C. So for letter C, how many are the even numbers? We have 7. And the probability of event C will be 7 over 15. And this is already the lowest term. So we are able to solve for A, B, and C, or probability of event A, probability of event B, and probability of event C. Now, let's use these answers in answering letter D and E. So let's have first letter D. What is the probability of getting less than 6 or greater than 9? So first, you have to identify if these two events, less than 6 or greater than 9, are mutually exclusive events or non-mutually exclusive events so that you'll know if what formula are you going to use. So less than 6 and greater than 9. So we are going to use this less than 6 and greater than 9. Is there something common with the elements here and here? Is there something common? 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15. So there's no common. It means that the events are mutually exclusive events. And the formula that we're going to use is probability of A or B, or probability of A union B, which is the symbol, equals probability of event A plus probability of event B. So since there's no intersection, we cannot subtract the intersection here because the events are mutually exclusive events. There's no something common. Alright, so and then let's substitute. So probability of event A plus probability of event B. So probability of event A is 1/3 plus the probability of event B, which is 2/5. Okay, so if you would like to solve, just use the original answer, 5/15 and 6/15. Okay, so we have 5/15 plus 6/15. Okay, they must have the same denominator so that for you to be able to add. 5 plus 6 is 11/15. Okay, so the probability of getting less than 6 or greater than 9 is 11/15. So in percent, this is 73% if we're going to round it up to the full number. So 73% is the chance of getting less than 6 or greater than 9. Okay. Now let's have letter B, less than 6 or even. So let's check first. We're going to use less than 6 and even. So check if there is something common between the two. Okay, so we have 2 and 4. We have 2 intersection. All right, so so we can say that this question, less than 6 or even, the events are non-mutually exclusive events because there are common elements or intersection. So therefore, the formula that we were going to use is A or C. Okay, or probability of A union C is equal to probability of event A plus probability of event C minus the intersection probability of A intersection C. Okay, so we already have the probability of event A, which is 1/3, and the probability of event C, which is 7/15. All we need to do is the probability of the intersection of A and C, or event A and event C. So how are we going to solve for the intersection? So probability of A intersection C. Okay, so as you can see, we have 2 common elements, 2 and 4. So therefore, this is 2/15. So the intersection will be 2/15. And then after that, you have to solve 1/3 plus 7/15 minus 2/15. Guys, you can just do it directly on your scientific calculator. So 1/3 plus 7/15 minus 2/15. The answer that we're going to get will be, okay, it's 10/15. 10/15 or 2/3. Okay? Now, how about the percent? Okay, so round it up to the nearest whole number. So the probability of getting less than 6 or even will be 67%. All you need to do is to multiply 2/3 by 100 for you to be able to get the percent, which is 67. Right? So if you have questions, most especially to my students, please don't hesitate to ask or send a personal message. Okay? Now, these are the answers. Let's have the second question. Find the indicated probability. So we have for A, and then we also have for B. Okay, so guys, here we just need to simply use some algebraic techniques to solve for them. Probability of event A is equal to 0.65. Probability of event B is 0.30. Probability of A union B is 0.75. And probability of A intersection B is. Okay, so as you can see, there's an intersection because so therefore we can say that probability of event A and B are non-mutually exclusive events because there's an intersection. So the formula that we're going to use is probability of A union B, or A or B. You have to remember, for you to be able to identify what formula you're going to use, first is check the word or. If it is or or it means that you're going to use the formulas, one of the formulas for union of two. Okay? So probability of A union B is equal to probability of event A plus probability of event B minus the intersection probability of A intersection B. Then substitute the values. Probability of A union B is already given, which is 0.75. Just substitute it. Then probability of event A is 0.65 plus the probability of event B is 0.30 minus the intersection, which is probability of A intersection B, and it's unknown. Right? So let's just apply some algebraic techniques to solve for this. First is we will be adding 0.65 plus 0.30. So therefore, this is 0.95 minus probability of A intersection B equals 0.75. And then after that, we have to transpose 0.95 to the left side for us to combine the similar terms. So 0.95 will become negative 0.95 equals negative probability of A intersection B. And then just combine, subtract rather, 0.75 minus 0.95 is negative 0.20. And then bring down probability of A intersection B. Since there is a negative here, we have to divide both sides by negative 1 to remove the negative because we cannot have a negative answer here. So therefore, the probability of A intersection B will be 0.20. So this is now our answer. See, it's very easy. Now, on sub-letter B, probability of event A is equal to 0.55. Probability of event B is equal to 0.35. Then probability of A intersection B is 0.15. Then let's identify what is probability of A union B. So these events are still non-mutually exclusive events because of the intersection. Right? So the formula that we're going to use is the same. A union B, or A or B, is equal to probability of event A plus probability of event B minus probability of A intersection B. And then after that, substitute the values. Probability of A union B is unknown, so therefore we cannot put any value there because that's the one that we are solving. Probability of event A is 0.55 plus probability of event B is 0.35 minus the intersection, which is also given, 0.15. And then after that, just combine 0.55 plus 0.35 plus minus 0.15. It is simply 0.75. Probability of A or B is equal to 0.75, and that 5, and that's our answer. Okay, so let's proceed. A card is drawn at random from a deck of 52 playing cards. Find the probability that the card is an ace or a king. Then for letter B, a king or a diamond. For an ace or a king, okay, so let's say identify first if these two events are mutually exclusive events or not. Ace or a king. Is there something common? Let's just try to imagine the aces and the kings. Is there something common between them? No. So therefore, so let's identify first if these two events are mutually exclusive events or not. Getting an ace or a king. Okay, so let's just try to imagine the deck of cards or the 52 playing cards and then look at the aces and the kings. Okay, so for all we know, we have 4 aces and 4 kings. Is there something common between them? No. So therefore, we can say that the events are mutually exclusive events, and the formula that we're going to use is probability of event A union K is equal to probability of getting an ace plus the probability of getting a king. But first, we have to solve the individual probability of getting an ace. So how many aces? We have 4 over 52. How many kings? We have 4 over 52 as well. So if we're going to simplify this, this will be 1 over 13. Same as this, 1 over 13. Now we can substitute 1 over 13 plus 1 over 13. So we have 2 over 13, or simply a 15%. So just multiply 2 over 13 to 100. So this is 15%. So the probability of getting an ace or a king, and the events are mutually exclusive events, will be 15%. Now let's have letter B, probability of getting a king or a diamond. So how many kings do we have? We have 4, and then diamonds we have 13. Now, is there something common or intersection between getting a king or a diamond? Yes, because there is a king of diamond and that's just 1. So the formula that we're going to use, since these are non-mutually exclusive events because they have something in common, will be probability of getting a king or a diamond is equal to probability of getting a king plus probability of getting a diamond minus the intersection of the two. Alright, so let's solve for the individual probability. Probability of getting k, we have 4 over 52 or simply 1 over 13, same as this. Then probability of getting diamond is equal to 13 over 52. And the lowest term of 13 over 52 is 1/4. And the intersection probability of the intersection of king and diamond will be 1 because we only have one king of diamond over 52. Now we can substitute 1 over 13 plus 1/4 minus 1 over 52 will be, okay, so the answer that we can get here, the probability of getting a king or a diamond is 4 over 13. Just simply use your calculator, or, okay, 31%. So just multiply 4 over 13 by 100, you will be getting 31% if you will be rounding off to the nearest whole number. Okay, so I hope that you can follow with our discussion about union of two events. Just remember, for you to be able to find out if it falls under union of two events, we have to have the word or between the two compound events. And then, of course, there are two formulas. The first formula is for non-mutually exclusive events, wherein when we say non-mutually exclusive events, these events have intersection or something in common. And then for mutually exclusive events, there are no elements that are common between the two events. Okay, so I hope that you are able to follow with our discussion for today. Now, for the activity of my students, please don't forget to do this one. And then I do hope that you've learned a lot in this specific session or discussion about the probability of compound events and the union of two events. And then for those who are not yet subscribed, please don't forget to hit the subscribe button and the notification bell for my videos. Thank you so much and have a great day.